Ladies and gentlemen, on behalf of the Finnish Academy of Science and Letters, I have a great pleasure to welcome all you to this seminar, which has got the name The Brilliance of Science, the Role of Women in International Science. And this is jointly arranged by the Italian Embassy, the Istituto Italiano di Culture, and the Finnish Academy of Science and Letters. We discussed a long time about the title of this seminar. From the academy side, we first suggested to have simply the brilliance of science, due to the fact that today we will hear presentations from world-leading brilliant scientists. Then we got the comments from to this suggestion from the Italian Embassy. And they said, this is in citations, we would like to put more emphasis in the event on the role of women in international research, rather than focusing on any specific scientific area. And Italian Embassy wanted to add in the end of the seminar title, The Role of Women in International Science. Excellent suggestion. Today we will hear the presentation from three fabulous scientists, all women scientists. And now I am in the situation when those organizers who put the schedule minute by minute asked me to use a couple of minutes longer time because the schedule has changed a little bit. And I started thinking that it's a very pertinent question how we get more this kind of excellent female scientists to contribute to high-level research in Finland, in Italy, and globally. This is a little bit sensitive topic even in Finland. We organized in Turku the event called Women in Science this spring. And we thought that we would like to give some advice to younger scientists, mainly women scientists, so that they will get advice how to go through all the problems which come up. And then we had it in the Biocity building in the big lecture theater, and it was almost full of young scientists, mostly women. 2 boys were there also sitting. And they were invited from Finland, the top scientists, female scientists we had, and also the younger ones we had also from abroad to tell about their experience. And we wanted to support and advise young colleagues to reach their scientific goals during their career. There are still too many hidden, invisible, or ignored obstacles for women scientists. But we must be active, alerted, and brave to improve the situation, despite the reputation we easily get as fussy and hysteric women when we are talking about these things. And there was the statement from one of the senior lecturers, which we kind of took very seriously. And this is almost from word to word what she said. The women scientists who have gained high status and international recognition in their research make the biggest possible crime if they do not use their experience and knowledge to help advance and encourage the career development of young women researchers. And I want to leave this message to you. it's not only women, young women researchers, today also young male researchers need quite a lot of support because the time have got more tough in getting funding to become independent researchers. But now I go to the program itself. May I have it here? Sorry. We will have first the ambassador of Italy, Mr. Giorgio Visetti, will welcome you as the other host of this seminar. After that, the permanent secretary, Anita Lehikoinen from the Ministry of Education and Culture, will give her welcome address. Anita Lehikoinen is our closest partner when discussing about the concrete ways and financial possibilities to advance science and develop universities in Finland. After these two presentations, the invited scientists will give their talks. I will shortly introduce each of them in the beginning of their talk. Then we will have a coffee break after these two presentations, and due to unexpected and unavoidable change in the schedule of Dr. Fabiola Gianotti, she will join us at 7 p.m. and will then directly deliver her talk. And now, please, Giorgio Visetti. I give the stage to you.
Well, good evening, Permanent Secretary, distinguished President of the Finnish Academy of Sciences, ladies and gentlemen, dear students. Italy and Finland share a common understanding of the centrality of scientific research, both for the pace of development through constant innovation and for the advancement of knowledge to mankind, to humankind. The seminar is firstly a tribute to the role of women in science and research, so well represented in this audience, and confirmed by the first ever female Director General of CERN, Dr. Fabiola Gianotti, who will tell us all about CERN and the fascinating program of this outstanding European and international research project. The level of participation in this seminar is a most telling example of the interest in promoting a centrality through a deeper dialogue and cooperation. In this regard, allow me to thank once again Professor Aro for her enthusiastic support of the seminar since the time it was just a sketch on a paper, as well as our illustrious women of science, Dr. Gianotti, who, as we heard, will join us later, having had to participate to the funeral of a colleague working in CERN this morning, actually a director of a department, and Professor Bracco, who have eagerly accepted our invitation, Rector Jukka Kola for hosting us in such a beautiful auditorium dedicated to a Finnish man of science, mathematician Lars Ahlfors, who embraced a mission of international research and cooperation. Mapping the scientific cooperation between Italy and Finland is not an easy task, since the articulation of the collaboration between universities, centers of excellence, and research often eludes the radar of monitoring of institutions. However, I would briefly like to mention some of the avenues along which our two countries have established fruitful and successful cooperation over the last few years. Let me start with the cold north, where an Italian company, EGIOS, a leader in Earth observation, has launched a partnership with the Finnish Institute of Meteorology for the provision, through the Cosmos SkyMed satellite system, of observation data that can be used for monitoring the effects of climate change, ensure safety of navigation along the Northern Sea route, support the development of local communities through sustainable use of natural resources. Italy's scientific contribution to the study and exploration of the Arctic in this respect dates back more than 100 years. And Italy's support to Finland is as evident as the one that will, in the forthcoming future, bring the EU Arctic Information Center to Rovaniemi. I cannot but support and even closer scientific cooperation between our universities, academies, and researchers, and concrete project and proposal in this field. It is also worthwhile mentioning the initiative put forward by the Visetti and the Polytechnic University of Milan and Aalto University, built upon the development of a platform for the exchange of researchers, funded in its entirety, as much as 600,000 euros, by the foundation of the Cariplo Foundation and the Polytechnic University of Milano. Whilst exhausted in 2014, the project might serve as a best practice and model base for promoting instrument and way to enhance and increase the mobility of researchers between our two countries. Besides, fostering youth and student mobility is of paramount importance to build competence and knowledge of our common future and that of an open and outreaching Europe. More recently, the Embassy has been promoting a more structured dialogue between the Italian and Finnish innovation ecosystems. Italy, on the one hand, has been facilitating the landing of Italian startups into the world-renowned Finnish system of incubators and accelerators of ideas, while on the other hand, trying to forward ideas who have been incubated or accelerated in Finland into innovative products that can be marketed worldwide, exploiting the levers offered by the Italian network on small, medium, and large enterprises. These are but a few of the areas of cooperation developed between Italy and Finland, well aware that there is still a big potential that we can tap into, both at bilateral and multilateral level, and of course European. Internationally, I strongly believe that Italy and Finland can champion together the vision of a strong and innovative European Union based upon a competitive European innovation ecosystem. In this regard, we need to act together in order to strengthen the European research area through the empowerment and enhanced mobility of European researchers within the EU. We can follow the lead and the example set by CERN in a few months under the Directorate General, Gianotti. Besides the cooperation within the EU, a common approach has been pursued by Italy and Finland also in the international support of science and research to the end of filling the gap in the scientific divide across the globe. Social and economic growth is one of the main results of science, technology, and industrial development. Only overcoming inequalities in the access to know-how and to scientific knowledge we can foster the fight against poverty and the reduction of imbalances in global development. This is the reason why Italy has been constantly committed in the development of scientific and technical cooperation for economic growth and sustainable development. Such a commitment has been mainly put forward within the system of the United Nations as the main forum for pursuing international cooperation. A well-known example of the Italian leading role in the promotion of science and research within the United Nations is offered by Trieste, a European city at the crossroad between north and south, east and west, who hosts three of the most prestigious international centers for advanced scientific education and research, working with developing countries and emerging economies. the United Nations Center for Theoretical Physics, the World Academy of Science, and the International Center for Genetic Engineering and Biotechnology. A more recent addition, in 2003, Italy decided to host also the network of International Center for Relativistic Astrophysics in Pescara. Within the European Union, the Italian-based ISPRA and its joint research center draw on 50 years scientific work experience built through 7 scientific institutes hosting research facilities and laboratories serving the Directorates General of the European Commission in addressing societal challenges and support for policy making in areas such as healthy and safe environments, secure energy supplies, sustainable mobility and consumer health and safety, supporting investment in knowledge and innovation related to the Horizon 2020 work program. Let me conclude, well aware of the interest of the audience to hear so distinguished speakers and of the golden rule of synthesis among scientists and to Finnish audiences. I leave the floor to the Permanent Secretary, not without thanking again all those who made today's seminar possible, and personally my Deputy Leo Bartoli for taking us here. Hyvä tutkimus.
Your Excellency, ladies and gentlemen, unfortunately the Minister for Education and Culture could not be here as she is defending our budget in the Parliament today. So it is a worthy cause to be away. I'm sure everybody agrees with that. I absolutely love the title of tonight's seminar, and everything in it is in its place. The brilliance of science. So this is what we want. We want top-class science, and we want it to be international by definition, by nature, as some say it is always. But in Finland, we still know that we have a workload ahead to be international, truly international in all fields of science. And obviously, to make it brilliant science, to make it brilliant, to make it international, we need more women in science. And if we talk about science as such, and we all know that there's a little bit difficulties in trying to translate science, whether it means in Finland only the natural sciences or does it only mean research, as it were. But especially in science, in natural sciences, we still have a considerable lack of women at the highest possible level. But to start from the beginning, you know that the Finnish society, we have been very active in promoting women's role in society at large. From the very beginning, we have been famous for the kind of gender-aware politics and policies in the country. And we were among the first to have this voting rights for women also already in 1906. And I think it becomes to many of us, also to Finnish people, as a surprise that when we take a closer look at our education system and the labor market, we can find out that we are actually a very segregated land. We still have very almost predestined paths for girls in education and science, and then we have the specific tasks for boys and men in our society. And this is not the way forward. The big idea behind the Finnish success has always been that we can mobilize the talent of the whole nation, and we keep the whole age cohort in education, obviously the comprehensive education, and then the goal is that everybody should have at least upper secondary education and training in Finland so that they can get by in Finnish society, to find placement in the labor market or then in studies in either polytechnics or universities. So why then do we not change the long-term traditions of having girls choosing the kind of soft fields in education and men then playing the leading role in natural sciences? And we can't change this situation if we start at the university level and if only we start to talk about the problem when we talk about research careers, because these choices are made at a very early age. And the question is whether they are really made decisions and choices that are done that people are aware that they are making choices. And the responsibility of our school system and already the early childhood education is very important. We know that people and small kids learn the patterns through education. They get the examples at home, and we can see that the education system, no matter how good it is in Finland, still produces the same patterns generation after generation. And this becomes very clear when we take a look at how girls see themselves as learners in mathematics or natural sciences. Girls are doing better in school in almost all subjects. And then when they get number 7, which is kind of okay in mathematics, they think that they are very bad in mathematics because they get 9s and 10s in other subjects. And girls seem to be very sort of serious when they evaluate and assess their own performance. They think that they do worse than they actually do. And this is, again, we can see that this is true when we take a look at the research done in these fields. So when they reach the 5th or 6th class in the Finnish education system, they have already formed a kind of image or picture of themselves as being very weak or poor in mathematics and sciences. And thus they make the kinds of choices at the upper secondary education that they can't really then make the move to science career in university. And this is the thing where we have to get the change ahead. Because now we see that there are more and more women who start their studies in universities and polytechnics, and women complete their studies much more often than men in Finnish universities. And this is true, I'm sure, also of Italian higher education. But then how to promote the women's path to the actual top of science and research? There I think it is also a question of tradition, and as Mr. Ambassador referred to the fact in the opening speech, that we have these hidden, unseen hinders that are very difficult to get rid of. We know that we have the legislation in place, and we know that the Academy of Finland has since the 1980s done a lot to take the positive view to the minority gender in the application rounds. But we see that the changes are too slow, and the higher we go in the academic orders or the ladder, the fewer women we see on top. And this seems to be true also in other European countries and obviously at global level. And there are some unfortunate changes also in Finland if we look at the leadership in universities. So we can't boast with a better situation than in many countries. And if we take a look at the European Union situation, only 1 in every 10 universities has a female rector. And now that we have really changed and reformed the university systems in many countries, that the rectors really can make a difference how the university works, then it becomes all the more important to have also female rectors in universities. And I might be saying too much when I say that in earlier times, it would have been not so important when the government, as in the case of Finland, we actually made all the decisions for the universities. But now that the universities are legal entities of their own and the autonomy is really strong, it really is important to pay attention to the leadership of our universities. And as Mr. Ambassador was talking about the competitiveness of European Union and how much we are relying on the change capabilities of universities, both the education and the research sector of it, to change the kind of, I would say, almost dismal future of European nations. So we have to get all the talent mobilized. And that's the kind of thing behind, I think, would call it a driving force when we think about the role of women in research. It is not just that we want to be on equal terms, but we want to make changes happening in Europe, and we have to have all the talent pool of our nations used and in best possible use. And we can't keep on losing the best, perhaps the best part of our young people in this way. So it is also in economic terms, it is a big issue whether we can have women in high positions and doing remarkable research careers in Finland, in Italy, at European level, at the global level. So I think the most difficult reforms to carry on successfully are those that require a change in culture, in the ways we behave and we think, because then it is so very difficult to charge the ministry or a working group to make the change happen during this 4-year period that every government has here in power in Finland. It just doesn't happen in 4 years, no matter how hard we try. And that's why in Finland especially, and also I would say at European level, we have to make the change happen in those people who teach our small kids through the education system. So they have the people in their hands for at least 12 years. Most of the big thinking patterns developed during those years. And if we can't make change happen in those little minds maturing, then we just keep on following the situation and we make all kinds of action plans for people like ourselves, and then we think that nothing changes. So teachers are educated in universities in Finland, and we tend to be very proud of it. So perhaps one day we are ready to make radical changes to our teacher education, to the education contents of those teachers who teach the smallest kids. When we talk about science and research, we tend to focus on too high a level. Yes, the root reason might be on the early childhood educators and the educators in our comprehensive schools. So this is perhaps the one thought I would like to leave you with, and obviously all those splendid and remarkable women we have in science and research, they set an example, and they really have a task to be a role model for younger women. And we have to be very aware of the hidden obstacles and also of our own attitudes. If we still find, as is the case, at least in Finland, that in many cases you see still these all-male panels, and those panels who choose and make appointments to very important posts, if they only include male participants, male experts, then the change will still be something that we can discuss the next generations. But I hope this will not be the case, and I warmly thank the Italian Embassy for this very fine idea to include the role of women to the title of the seminar, and still we have to find the ways also to make science brilliant, to make it international, and to make it more equal for everyone. Thank you.
And now the first lecture will be provided by Professor Angela Bracco. She comes from the University of Milano and Dipartimento di Fisica. Angela Bracco is a full professor in physics and leads a group in Milano working with experimental nuclear structure with gamma spectroscopy. Her investigations on stable and radioactive beams of nuclei at extreme conditions of temperature, spin, and angular momentum have made numerous breakthroughs in your research field. She also has a number of international responsibilities in high-level boards and committees, and was the first woman entrusted with the role as a chair of the Nuclear Physics European Collaboration Committee, abbreviated NUPECC. You have also the position as a chair of the Nuclear Physics Board in INFN since 2005. And I think this is now completely different from this previous one I mentioned. Yes, okay. Professor Bracco, you are the most welcome to deliver your lecture, please.
Okay, so in the meantime that my presentation will be on the screen, I'd like to thank the organizer for this very nice event and all these distinguished people present in this particular event. So I also thank Eva-Mari Aro, because she gave a good introduction of what I'm doing. So you can imagine that, of course, my presentation will concern a lot of what she said in my introduction, in her introduction. So, as I said, I put up this title that looks a bit impressive given the title of your event. But in principle, what I'm going to discuss here are two things. First, I will say something about is that okay for the sound? No. So if you want, I can use this. Hello. Because it sounds that there is some, do you want me to use this then? And I can still use the, because I think this is a bit too noisy. Sorry about this, but it looks. Hello? Okay. So now it's better. So, so the outline of my presentation is something about my research activity and also my particular contribution on science, but not only, but how to manage science nowadays. And then, because of the title of this event, I will try also to make some remark on the role of women in science, but of course, I will be using data mainly connected to the Italian Institute of Nuclear Physics, for which I've been working very much, and also now my research is funded by this institution, and some from the university. Okay, so let me start saying a few words on how this research that in nuclear physics is conducted nowadays that concern basically the origin of element and why they have particular abundances on Earth. So this is one of the key questions that is addressed by modern nuclear physics. And just to have an idea in a schematic way of what we are doing, I just show the picture, the schematic picture of the Big Bang that, of course, most of the students here present know very well. And in this picture, I just want to point out that only at the Big Bang level, only few elements up to lithium can be formed, and all the other very numerous, many elements that are present on Earth instead are related both to the birth, life, and death, and explosion also of stars. So understanding the abundances and the origin of element is therefore a very exciting work that has to be done in cooperation between different science, from astronomical observation, some model, of course, astrophysics model, but also nuclear physics. And the particular role of nuclear physics for the understanding of what we call the nucleosynthesis in star is really to produce this element in the laboratory. And of course, to produce this artificially in laboratory, one needs particular equipment, and in particular, accelerator of particles. So another picture that shows, again, in a schematic way, what is the situation about the elements that we know on Earth. So if one plots, in general, one plots the element using as a horizontal axis the number of neutrons that are inside the nuclei and the number of protons. So the black points that are present in the middle, in the kind of a diagonal of this plot, of this figure, are the 248 elements, stable elements that are present on Earth. The pink and the light blue areas are instead the isotopes that were synthesized in the laboratory, and for which now there are a lot of present studies to understand their structure, how interactions somehow perform or give effect inside nuclei. So for example, I just put an example how for particular coupling related to their motion or to their angular momentum are producing effect in nuclear structure. But of course, the theory will predict that not only this 3,000 element, but on the order of 6,000 elements should be present when the stellar explosion occurs in space and to form the, let's say, the precursor of our element. So you can understand now that to try to search for this 6,000 element, or let's say extra 3,000 element, and to search their property is really a difficult task and very challenging also from the technical point of view. Okay, so this to introduce the topic. So now the question is, where do we do this kind of research? So this is a kind of a distributed research, because in contrast to what will be discussed by Fabiola, where particle physics is mainly concentrated at CERN, this research is carried out in several laboratories in the world. And so because it's distributed, as you can understand, is very important in order to have success and really to progress in an outstanding way, to have a coordination and also to really guarantees that all these centers are somehow complementary, and but they need also synergies. So it's very important, the coordination. So I will not, of course, talk about all this laboratory. I have selected a couple of ones that are in Italy, one in Finland, of course, and the case of CERN, because it's also an activity that is related to nuclear physics. Okay, so first of all, as I said, INFN, I already mentioned that there is the Institute of Nuclear Physics in Italy that is the funding agency for particle, astroparticle, and nuclear physics. INFN has two laboratories. One that is called Legnaro, that is the bottom one that is close to Padova, and the top one is called Laboratory of South, and is located in Catania. So here, as you have seen in my previous transparency, of course, those laboratories do not only do basic science, but they also have a lot of spin-off and applications. So, for example, in the Laboratory of South, where there is one of the first superconducting cyclotron, they do, of course, research concerning the nuclear equation of state, but not only, they do applications in connection to medicine. In particular, they do some eye cancer treatment using directly the proton beams coming from this machine. In the Laboratory of South, Legnaro, close to Padova, of INFN instead, again, there are several accelerators inside here, very, let's say, cutting-edge instrumentation to do the experiment, also some application, and, for example, the new project that is now under construction in connection to radioactive beam that is indicated with this yellow area. This also will have some applications, in particular for the production of radio, or let's say first research and then production of radioisotope for medical applications. Now let's go to Finland, where you have this beautiful institute in Jyväskylä, close to the lake here. And this is actually, is a center of excellence for the Academy of Finland. And this is a laboratory for nuclear and accelerator-based research. Also inside here, these are pictures of something that is inside those buildings. It's not, of course, everything. But I just want to point out that there are several accelerators. One of them, low energy, is dedicated to material science application. The other is more for basic research in nuclear physics. And one of them is also to develop some technique. So here there was some pioneering of special technique together with CERN Isolde. And this exchange was very fruitful and is still going on and is very important for also the future program. And also the other specialization is the study of the property of what we call super heavy element. So I like to point out a couple of nice results of this laboratory in Jyväskylä. I just want to mention that this laboratory is also as a transnational access. So that means that the users are mainly European. So most of the users are from outside Finland. So it's a laboratory with transnational access, international transnational access. So some results, I just try to pick up some that are most, let's say, easier to transmit or to convey to the more general public. So one concern the study of element transuranic. You know what is uranium? So there is not so much about element so much known about element beyond that are heavier than uranium. And of course, there is an interesting physics there to understand how they can survive in spite of the strong Coulomb repulsion. Another interesting topic is the concern, again, the nucleosynthesis, the formation and abundances of carbon-12, that of course carbon-12 is very important to explain the origin of life. And again, they need some precision measurement to study particular configuration that can explain why we have so much carbon form in our galaxy. In CERN Isolde, that I already mentioned, this is not only, of course, to please Fabiola. As you know, Fabiola is from Milano, where I come from. Of course, we are very proud of her, and she's on our beginning of our web page. But because I think it's very important to point out this collaboration with CERN. So there is a facility which is called Isolde. And at Isolde, again, there are a lot of experiment, or a very rich program, I must say, concerning formation of nuclei that are not in a conventional shape or in a conventional structure. And one of them appear in nature, and is a very important result on the fact that some nuclei can have a kind of a pear shape, like a pear, and this the fact that there is this pear shape has some consequences on the standard model of particle physics, in particular in connection to the breaking of fundamental symmetry. I mentioned because some people here are experts like CP or time reversal invariance. Anyway, so these are very important. And another one that I pick up among the nice numerous results produced at Isolde is the one on atomic physics. There are very rare elements, like this case is the case of astatine. And this astatine was not known even from the atomic point of view. For example, how much energy is needed to extract electrons was not known. So this research gave information not only on the nuclear part, but also on the atomic, and this of course has consequence on application, and in particular astatine is one of the isotopes that is being considered also for the cancer treatment. So as I mentioned before, we need coordination. So this is in order to guarantee the success of this research and the complementarity. So NUPEC is that was mentioned at the beginning, is an expert board of the European Science Foundation that include, we have 21 European countries that are members, and the major role, the major mission is to enhance the collaboration among the different countries on issues related to nuclear physics, or let's say nuclear science, and promote also the applications. Another important task of NUPEC is, of course, to keep, as I mentioned in my transparency, that there are also a lot of effort done outside Europe, in particular US and Japan and let's say the Asiatic area. And so it's very important to keep contact with them, especially when they decide their future program. And this is done again via NUPEC. We have somehow observers from their board, and we also go to some of their meetings to discuss more globally, let's say really globally, this science. And I just also point out that also Dubna has recently joined this. So what is the task of NUPEC? As I said, is not only to make the collaboration, to enhance the collaboration, but is to build what we call the long-range plan, let's say the roadmap for in this field, usually for the next 5 to 10 years. So the idea is really inside is to lay down what are the prospect of building new facility, to upgrade a major existing facility, but also to enhance the collaboration with the smaller scale facilities that are usually located at the university. So until now, NUPEC has produced 4 long-range plans. The last one is 2010, and now we are getting ready to produce the next one for 2017. So NUPEC is a quite old, let's say, board panel that exists now for 27 years. 2 years ago, we celebrated the 25 years. And we have a magazine that is distributed every 3 months that is called Nuclear Physics News, that goes to 600 people working in this field around the world, not only in Europe, of course. And we had a particular issue dedicated to the 25 years of NUPEC. So you see this in the picture. I circled the picture of Aisto, Professor Aisto here. That was a former, that is now presently the director of Helsinki Institute of Physics, but he was one of the former NUPEC chair. So I'm very honored to have been preceded by Aisto, Professor Aisto. In the meantime, we don't do only, of course, preparation for the long-range plan or the strategy, or you want to call it, but we produce specific report, somehow summarizing and putting some motivation for the future in some applied area of nuclear physics. The latest one, I don't mention all of them, but I just mentioned the latest one that was produced last year, that is called Nuclear Physics for Medicine. We like to see how so we point out here how basic research propose really innovative ideas for application for the benefit of the society. This report that can be found, sorry, this is not so visible, but maybe I leave the transparency, can be found on the web page of NUPEC, so I invite you to download it. And so this report is divided into 3 main chapters. One that is called hadron therapy. I already mentioned that in Catania there is the use of protons to cure the eye cancer. But of course, this is not the only case. There are several centers in Europe that do this. So one is devoted to hadron therapy and also the improvement that can be done in the future, in particular in connection with the carbon therapy. The same therapy using carbon beam. So this is the one chapter. Another chapter, as you know, that is very important in medical diagnostic is imaging. So one is dedicated to the progress in imaging, in particular with gamma technique, that are important to improve the quality of the diagnostic. And the third chapter that I already mentioned also in connection to one of the laboratory is the production of new radioisotope. Of course, there are some ideas to really replace some of the radioisotopes that are presently used, particularly because some of those are produced in reactors, and some reactor will be shut down. So to really go into production using more conventional machine that like accelerator that we use also for basic research. The last point concerning the NUPEC is that, as you know, this year is the International Year of Light. And so NUPEC has prepared a brochure showing up, really emphasizing that basically the electromagnetic spectrum in a broad sense is very much used to do research, to understand the basic of nuclei and of nucleon, and to do instrumentation. And of course, there are also a lot of connections that are related to astrophysics and medicine. I want to point out that this brochure was prepared by NUPEC, but it was also sponsored, and we got a lot of help also from the point of view of financing it, by the new infrastructure that is called ELI Nuclear Physics, Extreme Light Infrastructure, that is going to be built, is under construction in Bucharest, and where, of course, there will be a lot of experiment to study nuclear reactions and to induce nuclear acceleration via laser and gamma beams. So now I get to the second point of my presentation. So some remark on the role of women in science. As I said, I will restrict myself to INFN because, of course, I got the data from the committee that is taking care of the equal opportunity. So what we see here is the standard picture. So in this plot, is in red is the fraction of women working in this field, and in blue is the fraction of men. So you can see, then I will give you in the next transparency the exact number, that this number is of the order of 20%. So there is a big asymmetry. This asymmetry is somehow common in many countries, although one should mention that in case of Italy, Spain, and Greece, is slightly better than other countries. So the possibility of being still not satisfactory, of being slightly better, is that in this country maybe this science, the natural science, are perceived like more as a discipline that has to do with the philosophy of nature, and let's say the technological connotation has less impact in this kind of choice. As I said, I just want to point out that INFN, this survey, of course, concern Italy is a big country, concern all the people that are working or associated to INFN in different areas. You see, we have 20 INFN sections plus 4 laboratories. So this is general, it's not only for nuclear physics, but it's for all INFN. So here again, this is how the thought of INFN employees. So we see that the 25% are women, and these 25% are mainly in research, not so much in engineering contribution. So here again, this is how the thought of INFN employees. So we see that 25% are women, and these 25% are mainly in research, not so much in engineering or technicians. This is the point. And of course, in the administration, we have a lot of women also. So, do we see some improvement as compared to what, is this still okay? No. As compared to what I show, I think this has given up, no? I don't know. Can you still hear me? Anyway, I try to speak loud because unless I touch something. Anyway, so this is the situation improving. In a sense, yeah, I continue, sorry. Is that okay now? Yeah. So in a sense, it is a little bit improving because in this plot I show the hiring. So the new hiring, what is going on every year when we hire new people. And if you see in the last one, that is 2010, the data, now the women that are in green are almost half of the men. So somehow there is, and of course we hope that this more equality, or we are convinced that more equality means an improvement in quality, as it was discussed before. So now only a few data from my university. So my university is one of the, belongs to the large university in Italy. It has 60,000 students. So it's not as big as La Sapienza, but it's one of the largest. And again, I put these are the people that registered last year in natural science. Again, physics is slightly worse than the other. And of course, life science as biology instead is really doing remarkably well, because I just put one data over that just to show that is really natural science that is the one that is not so much chosen. I just want to show that this is my group. We have a lot of women in my group. And unfortunately or fortunately, after they graduate, of course, they go abroad, not only in Europe. They go, also some, they go to Japan. They go all over the world. And so this is the situation. But in my case, I must say that I'm in a lucky position. And two more slides. One is, again, I went to look into literature or ask colleagues that are working in the equal opportunity. And I chose this survey that was made by EU. And I don't know if you can call it a surprise, for me it's natural. Among the different type of questions, why you choose science or not, most of the answers are really, they really have to do with the fact that they don't choose science because it's really somehow demanding, so it's difficult to reconcile a job that is really demanding in terms of performances together with conducting with the burden of life, so of family life. So again, unfortunately, even now, this was the situation when I started more than 30 years ago. So unfortunately, most of the answers are still related to the social condition of the difficulties of them. But I think that is something that you might have expected anyway. Concerning the European Physical Society, I just want to make a couple of remarks. One is that, of course, there is also there a committee, let's say, that looks into these kind of topics and try to understand better what are the barriers for women in physics in general, all physics. This is European Physical Society. And now the action that were recently taken by European Physical Society are two. They created an Emmy Prize for women. And then the other, let's say, action is to create, to put on the web page curricula of young scientists. Why young scientists? Maybe they are not yet let's say they haven't yet achieved what they want, but they are still an example, and the young people really feel that they are much closer in mentality and in the way of life than maybe the example of very old colleagues that have reached maybe higher position, but of course they are much different in age. So, and I think this, I hope it will work out to attack. This is an idea of European Physical Society. So we have to improve social conditions. This is somehow normal, standard conclusion that we have already discussed. So at this point, I just want to conclude that say that as compared, you know, that the investigation of nuclei somehow started at the time of Marie Curie, because of course natural radioactivity is a manifestation of an effect of nuclear physics effect. So that, but since then, a lot of progress has been made, and this progress is really made by using accelerator of any type of energy, high energy as in CERN in the case of Isolde, or even lower energy in many laboratories distributed in the world. So this basic research is done, as I said, in a very coordinated way, and will really improve our knowledge and also will give some benefits to the society. I must say that the challenge, therefore, is continuing, and this needs really the excellent work, dedication, and skill by many men and women. Okay, so I don't know if you have to ask questions. I did a little bit too long. Huh?
Okay.
It was too long.
Let's take
Questions?
We take one question. It will come later then.
Okay.
Yeah. Thank you. And our next speaker is Professor Irma Thesleff from the University of Helsinki. Irma Thesleff has received last year the highest recognition a scientist in Finland can ever receive. She was appointed the Academician of Science. In Finnish we call tieteen akateemikko, by the President of Finland. And after that appointment in 2014, we had 12 academicians in Finland, of which 9 were men and 3 women scientists. Now I have to say that something good has been happening, because this year we again got 2, and 50% men, 50% women, so that was great. As also in your case when you got it. Irma Thesleff has made a pioneering work in the field of developmental biology. She is an internationally highly recognized scientist with research interest in mechanisms of embryonic organ development, particularly on tooth development. She has been working broadly abroad and has been awarded with many international honors and prizes. Today, Irma will probably not talk directly about her great scientific achievements, as I see that the title is towards gender equality in Finnish top science. Please, Irma, we are very proud of you.
Okay, thank you very much for the nice introduction. So, Your Excellencies, ladies and gentlemen, I'm really very honored to represent the Finnish woman scientists in this seminar. I'm not going to talk about my science, although of course that is what I love, and I'm sure that you would be very interested in that also. But really today, in this seminar, I'm going to focus on the gender issues. I've been a scientist for more than 4 decades, which is a very long time. And already by the time when I defended my thesis in 1975, I already had recognized discrimination of female students and also scientists in the university. I remember then considering whether I should start campaigning for the gender equality and to be real activist, but then I actually loved to do my scientific work, and I rather worked hard in science and research, and I thought that the best that I could do for the gender issue was to try to develop a good role model for the next generation. And so, therefore, I'm really very pleased to be in this seminar here today, and I thank for the invitation. So, we have actually excellent role models in Finland. Alma Söderhielm, who was born in 1870, was the first woman professor in Finland, and she got the professorship in 1927, 88 years ago. So these ladies actually demonstrated that it is possible for women to do top science and in a big number of different scientific fields also. So these fields of these early scientists, specifically in the upper and part of the lower row, so they represented humanities, life sciences, but there were no physicists or chemists yet at that time. So many of these women actually then have documented their experiences as women scientists, and they have written about them. And their problems definitely were much more severe than we women scientists face today. But still today, the women are underrepresented in academic top positions. And this is the situation, of course, all over the world. The problems and the reasons, they may be somewhat different between different countries. For example, between Italy and Finland, and they also may differ between different fields of research, for instance, physics and biology. That the speakers today are representing here. So the representation of women in top positions in Finland is actually quite good compared to many other countries. So the 28% of women professors is one of the highest numbers in the world. This, of course, then is an average of all different fields, and obviously, for instance, in physics, it is very different from that. And in the I just checked before the lecture that in physics in Helsinki, 4 of the 30 professors are women, so that is kind of lower than the average 28. But anyway, so I, as I've written there, so the female salaries are lower, and the tenured jobs fewer for the women professors, which is unacceptable, of course. Well, then the top positions in Finnish science. Scientific world are the academic professors and the directors of the centers of excellence, as well as the FIDI-Pro professors, and specifically the academic professors and center of excellence directors. They are actually very high numbers there, and it must be said that the Finnish Academy, or the Academy of Finland, has taken this gender issue very seriously already for many years. So what are the reasons for the very high numbers of females, women in top positions compared to other countries? So the reasons very probably lie in the Finnish tradition, and in the very active politics. And as was already mentioned earlier by Anita Lehikoinen, so Finland has a very long tradition, and women have been equal for a long time politically. So Finland was the first country where women could were granted the right to stand for election in the parliament. They have a long history in academic studies there, and traditionally the women have worked outside home, and so it's I guess nowadays about 50% or something. I don't know actually the numbers, but basically almost all women work outside home. And what is important is that the society has facilitated the combination of work and family, and we have the long maternity or paternity leaves, and this right to stay at home for many years. And also the child care is helped. So this is, of course, all very good. But thinking about scientific careers, so this the long stay at home may not be very good for the progress of the career, and there is the possibility to divide that task between the parents, but still nowadays it is the women who mostly stay at home, and that of course is maybe detrimental for career development. If we look how this percentage of women among professors has changed during the years, so the progress was rather slow from the until 1980s. Because the first professor, as I thought, was appointed in 1927. So in 1983 there were still only 6% women. So we can ask that is it probable that this trend will continue? So there's actually a quite big increase during the last 4 years, from 25 to 28%. So these numbers actually they correlate also with the increase in PhD degrees, which certainly explains some of the increase in the amount of professors, and you can see here this increase from 2010 until 2000 and until 2014. So there has been a big increase, but also the PhD degrees are, or the percentage of women with PhD degrees is increasing. So then we can kind of ask the question: so could it be that with this increase, the professor proportion will also be increasing? But I guess it is rather unlikely that it will reach very soon the same percentages as the PhDs anyway. So this so-called scissors diagram is very similar in different countries, the European Molecular Biology Organization, EMBO, made a survey some years ago about the reasons and of the decrease of women. So it is typical that the women dominate in the lower positions in the university, and then there is this decrease to professors. And this EMBO survey indicated that actually the females lose out scientifically to the males during the time from the postdoctoral period to the starting of an own group, like as a principal investigator. And then after losing out scientifically, so they then also don't end up as professors as frequently as the males. So I guess we can conclude that there still is a problem, a gender disparity problem, and we should try to find out why it is, and why there are not more women among the top scientists, and what we could do to correct the situation. So there has been really increasing commentary and debate on the gender disparity in science. So there are a lot of surveys and reports and recommendations, and even some autobiographies of women about these issues. So questions that have been then made are that is there then actually discrimination of the women when these funding decisions are taken and professors are recruited? So is there discrimination, and would the application of gender quotas to the committee members of the funding institutions and universities help? And so these questions were taken already or asked some years ago, and there is again this European Molecular Biology Organization, EMBO, published just this September a report about whether these or gender quotas affect decisions. So the question of the gender quotas is important to ask, and actually in Finland these gender quotas were actually pioneered or their use in politics, and since '86 the political boards in Finland have had a 40% part of women, and as an example, Academy of Finland board has 50% of women, and internationally, so the EMBO committees now have 30% of women. But this EMBO report actually then explored whether there has been direct influence on decisions, and that is questionable, and which is actually a good news, so that increasing women in the panels does not result in more women getting the funds. So it means that the decisions, even without the women, the male decisions have been objective, at least in most parts, so that there seems not to be really influence on the decisions. Okay, but that does not mean that the gender quotas in the committees would not be a good thing. And the consequences have also been explored, and they are commented in this EMBO report. And there are negative effects and positive effects. And the negative effect is this quota stigma, which means that when women get funds and professorships, so it's often kind of concluded that was because they were women, and I guess all us women scientists have actually experienced it. I experienced this quota stigma. I remember it very well, the day in 1980s when I had just heard that I got my postdoctoral position from the Finnish Academy, from the Academy of Finland, and this was my first kind of the bigger grant thing. I was really happy. But then one of my male colleagues at the pathology department came and commented. He was a medical doctor. I'm only a dentist. And so he commented that, well, I understand that you got it. You actually had two good reasons, and so you are a female and you are a dentist. And this kind of is something that I never forget, and it didn't feel good because, well, everybody knows it, that because I thought that I really had done some good application and I deserved it, but then come these people who don't really think that I deserved it. So that is a problem, but we just have to live with it. So it doesn't it doesn't ruin anybody's career. Then also, negative thing is the burden for the few senior women scientists, and that is something that all the senior women scientists have also experienced. It takes a lot of time and effort to work in these different international committees or panels for funding decisions, because this quota of females and because there are so few females, so we just have to accept it and we have to be there. But these positive effects of these quotas are important, and that is why they really should be continued. And the first thing is that these quotas themselves, they increase the awareness of the gender issues, and so that people, both females and male, think about it and accept that they are present and think about positive ways to act. And then there is this other positive effect that I have listed. This I have not read anywhere or heard about it, but this is something that I think personally is a very important positive effect, because I feel that when I have been representing Finland or Helsinki or university and females in these many committees, so I have met a lot of important people, a lot of scientists in different fields, men and women, and which has resulted in not only friendships, but also in collaborations, in getting invited and getting visibility. So it actually is a very important thing for the senior scientists who are kind of approaching the top level. So it is a possibility for female scientists to become part of the circles. So the conclusion is that these gender quotas are a good thing, and they should be continued. So how could then universities and the research institute actually improve this balance? And here are listed the things that I think are key is the visibility to women and bring forward the women's issues and all the positive actions at all stages. And of course, also the focus of gender representation that I just discussed, so that should be remembered. So the big problem here still is the panels. And that was also mentioned earlier today. So all kinds of panels, they tend to be male-dominated still today. And here as a diversion here, so I will introduce this hilarious website to you, which has started and is run by two female, Finnish females, and the idea here is to document male panels. This is a rather recent panel website. So anybody can send their pictures there, and they should add this wholesome stamp here with their picture, and then they can also put some sentences explaining this. So here is just one example about the systems biology expert speaker series. And here are some other examples. This is about how to publish in high impact factor journals. So there are males, and about recognitions in some fields. So you see the males there, and more panels. It is actually quite funny to look at this. And then there was this recent picture from Helsinki Sanomat. And it is not only a couple of weeks during this financial crisis. And I remember that when I saw this, so I thought that, well, this does not look good. I mean, these 10 people, so is it really so that you cannot ask any woman's opinions on this? So this was, and even the jury of Tango Markkinat, which is the tango contest, is here. And as you all know, so there is also the women's contest and the men's, so separate, but only one jury. Okay, so these all male panels are a perfect example of the unconscious discrimination, and this is the thing that I'm going to discuss now as the last point of my talk. Because I think that this is the key to better future if we can fight this unconscious discrimination. So actually, what I wanted to say still here there is that this absence of the women, so it gives this impression that there are no women experts, and there's like a vicious circle when there is no visibility of women, and this thought that there are no women, and then the women are not asked to any other panels either. So, and this detrimental effect of this unconscious discrimination has been pointed out really for a long time. And these are the conclusions of the EMBO report, which I think is still very rather valid. It was a very well made survey, and this was based on applicants of the EMBO long-term fellowships. There were some 680 applicants between 1993 and 2006, and this is then the conclusions. They interviewed and did a lot of work in EMBO, and the number one conclusion was these traditional roles of women at home, and also their whole. That was also the title of their report, which was published. Was this traditional gender roles? So that was the main thing. But I think that in countries like Finland, this may not be, or it is actually at least improving, and it is not as bad as in many other countries. Of course, this is true, but they have listed in the third place here this element of discrimination against women. So I have just a few pictures of this unconscious discrimination still. And what I would say is that this should be really the key target to striving for the gender balance. So here the academic community should be really more active. And here then we ask actually, so how does this discrimination manifest itself? So it is just here like a word. So how does it manifest itself? And what kind of events are involved in this unconscious discrimination? And here I would like to actually cite Liisa Husu, or I'd like to tell about the Professor Liisa Husu, who is originally from the University of Helsinki, but now is a professor in Sweden on gender studies. And she has introduced this expression of non-events, which I somehow like. And that this means things that do not happen. And this is a quote to her text. So what they can be, so it is not being seen, heard, supported, encouraged, taken into account, validated, invited, included, welcomed, greeted, or simply asked along. So these are a powerful way to discourage, and so on, as you can read there. So what are the examples of non-events or common examples? And this is something that happens all the time, every day, is that women are not invited to meetings, networks, organizing committees, or speakers to conferences. And they are not, they do not receive, not necessarily receive the advanced task to represent their department, institute, university in committees and so on. And also performance may be ignored. And this is also a quote to Liisa Husu's talk, so that it is difficult to respond to non-events because they didn't happen. Actually, here I will just give a little example what happened just 1 month ago at our institute. So a young principal investigator, my previous postdoc, had received a task to organize an international conference in Finland with 400 people and in our field, and he did it then very independently, not asking many people, and then he came to me and was very proud that now the web pages are there and we are really far, and keynote speakers have been invited and so on. And when I went to the web page, there was the organizing committee consisting of 4 males, and the invited 5 speakers were all males. So I was furious, of course, but this couldn't really be changed very much because there was not so much budget that they could invite some women also. Okay. So, in conclusion, so the thinking here is that there is a series of subtle disadvantages to women, which then have this cumulative impact. And that in order to help this, so the scientific communities internationally and nationally should be more active. And then the final personal comment. So I feel that support and positivity from my surroundings have really shaped my career in a very profound ways. So there was not a single discovery or publication that put me on the map in the international community. It included many different things. And I'm really grateful for my thesis supervisor first, and thereafter to numerous colleagues over the years who have supported me. I don't think that otherwise I would be an academician of science. And the very last picture was taken the day before yesterday, when I was mushroom hunting on Sunday. And then I realized that actually there is something that we share with the Italians, and it is the love to mushrooms, and specifically the ceps. And we got a lot of the ceps. So, thank you.
Thank you for the talks by now, and we have now a coffee break, and then we will have the last talk. We now already know that she has arrived, and everything will be fluently. But now let's have a coffee break, and then we'll be back 5 minutes past 7. Kello on jo noin paljon. Okay, welcome all back to the lecture hall. Dr. Fabiola Gianotti has now arrived. And I have a short introduction. She completed her PhD in experimental particle physics in the University of Milano, 1989. Since then, she has been a research scientist in the physics department of CERN, the European Organization of Nuclear Research. Her research achievements, honors, prizes, awards make such an endless list that I don't even try to start going them through. Indeed, there is almost everything you can imagine. But people in the world probably knows her best as a project leader of the Atlas experiment, which led to the discovery of the Higgs boson. It was also in our news, and we all know about that. And now, from the beginning of 2016, she starts as the first female director general of CERN. I want to say something more about your other activities. I think it's worth mentioning that you are also a member of the recently set up Scientific Advisory Board, member of the United Nations Secretary General, Mr. Ban Ki-moon. And you are also a very well-known person, not only in the scientific field, because you have been ranked among top 100 most inspirational women by the Guardian newspaper in UK, and among the most influential women by the Forbes magazine in USA. And I think it was very good because this is not especially for women, but you are listed by the Foreign Policy magazine among the leading global thinkers of 2013. So I could continue this forever, but now everyone is already anxiously waiting to see you and to listen to your lecture. Please.
Thank you very much, Professor Aro, for this very nice introduction. Very pleased to be here and very honored, and I would like to thank the Finnish Academy of Science and Letters Professor Aro in particular, and then the Italian embassy in Helsinki, in particular Ambassador Giorgio Visetti, and also the Istituto Italiano di Cultura, and the Ministry of Education and Culture. I'm also very grateful to the organizer for reshuffling the program at the last moment due to, unfortunately, an unexpected and very sad event. I think this has been already mentioned today, so I will not expand on it. So, inspiring myself to the topic of the seminar, the brilliance of science, in particular the role of women, I would like to show you tonight an example, a brilliant example of a scientific and successful laboratory, and the role of women also within this laboratory. So let me remind you that the CERN is the largest particle physics laboratory in the world. It's a place where over the past 60 years, scientists from all over the world have been doing fundamental research awarded by discoveries. The last one is the Higgs boson, and awarded also by Nobel Prizes. It's a place where the scientific goals require the development of innovative technologies in many fields that then we transfer to society. One famous example is the World Wide Web, which was introduced in '89 at CERN to facilitate the exchange of information among the scientists involved in the laboratory activities. And since then, it has changed the way society accesses information. I would like to open a little parenthesis on the web. Then I will come back also to other example of technology transfer to society. Of course, if the web had not been invented at CERN, sooner or later someone would have invented it. However, what this person would have done was to put a patent on it, so every time you click, you will have to pay. The fact that the web was invented by a research infrastructure funded with public money makes that the web is available to everybody for free. Another mission of CERN is training and education of young scientists, but also of school students and teachers. And CERN is also a very special place to foster peace and collaboration, peaceful collaboration, because it attracts more than 11,000 scientists from all over the world, more than 110 nationalities. So just one historical slide. CERN was founded in 1954 by 12 European states with the twofold goal, on one end, of restoring scientific excellence in Europe after World War II, and also to foster peace among European nations after the war. And today it counts 21 member states, all of them from Europe except Israel. In 2010, CERN has opened the membership also to non-European states, and of course Finland and Italy are two members of CERN. The budget is about 1 billion Swiss franc a year, and is contributed to by the member states in proportion to their income. Now, I would like to stress that 1 billion Swiss franc per year corresponds, on average, to 1 cappuccino per year per European citizen. I said on average because in Southern Europe, the cappuccino is very cheap and very, very good, and then you move north. Okay, fine. Now, Finland contributes 1.4% of the budget, so about 15 million Swiss francs. So this is what you contribute to CERN. Okay, so the primary mission of CERN is science. So what we do at CERN is to study the elementary particles, among which we also find the building blocks of matters, electrons and quarks, and the forces that control their behavior at the most fundamental level. So today we know very well that matter is made of atoms. Atoms are made by a central nucleus surrounded by a cloud of electrons, and nuclei are made of protons and neutrons are made of smaller particles called the quarks. And the quarks are bound together by other particles called gluons. Now, as far as we know today, quarks and electrons are elementary particles. It means that they cannot be cut into smaller pieces. And they are the fundamental constituent of matter. They are the fundamental constituent of atoms. So everything, myself, you, this microphone, this table, etc., we are all made of electrons and quarks. This is what we are made of fundamentally, and a lot of empty space. So part particle physics at modern accelerator, and the most powerful accelerator is the Large Hadron Collider at CERN, allow us to study, to scrutinize, to study matter down to the size of the quarks, so 1 billionth of a billionth of a meter or smaller. So these accelerators can be considered as giant microscopes, which instead of giving access to cells, they give us access to the smallest constituent of matter. At the same time, these studies allow us to understand the structure and the evolution of the universe. So the very small allows us to understand the very big. And the reason is the following. We know now, not only from cosmology, but from several very detailed experimental observations, that the universe had origin about 14 billion years ago from a big explosion called Big Bang. At the beginning, it was very dense and very hot, and then it expanded and cooled down. So at the beginning, the universe was essentially made of 3 elementary particles. And so by studying the elementary particles, we can understand how the universe behaved in the first instance of its life. Then with time, it expanded and cooled down, and so particles started to stick together to form first neutrons and protons, then nuclei, then the atoms of the lightest elements, and then the stars and galaxies and planets and the macrostructure that we know today. So it's interesting to note that telescopes, which allow us, of course, to study the universe, the macrostructure of the universe, are, of course, very important to understand the evolution and the history of the universe. However, they cannot go to earlier ages of the universe than 380,000 years. And the reason is that before that age, the universe was opaque. Light could not escape, could go out, and so this light could not come to us. So with telescope, we can only go back to 380,000 years from the Big Bang, and then we have a wall. So the only way to go to earlier stages is to use accelerators, because they allow to reproduce in the laboratory the same phenomena that have characterized the early universe at the level of elementary particles and their interactions. So how do we do in practice to perform the studies of the elementary constituents of matters and the impact on the universe? So what I'm going to say here is very scientifically not very rigorous, very simple. So don't propagate outside this room, please. Yes. I see some, I have a webcam or web microphone, so I'm a bit worried. Anyway, so what we do is essentially to accelerate 2 beams of particles, for instance, 2 beams of protons at the highest achievable energies, and to make them collide. So to accelerate beams of particles, we use accelerators. Accelerators are just a sequence of electric and magnetic field, usually housed in an underground ring. So here you can see a picture of the underground tunnel of the Large Hadron Collider, and these big blue tubes contain superconducting magnets. So these accelerators are rings, and so particles are accelerated incrementally at every turn. Every turn they get a kick and they are accelerated to the top energy. Then this particle collide, and in the collision essentially 3 things can happen, and we studied 3 things that are important for us. First of all, imagine these 2 particles like when you smash 2 big trucks against each other at full speed, they go in 1,000 pieces. And so in some sense, we make the protons go into 1,000 pieces. And so we can study how the fundamental constituents of the protons, the quarks and gluons, interacts. So this is the aim number 1. Aim number 2, from the energy produced in the collision, new particles can be produced. So, and the higher the energy of the collision, the more heavy can the produced particle be. So particles that have not been observed at previous accelerators because their energy was not high enough become accessible to the new accelerator, the most modern accelerator. So this is the reason why the Higgs boson was discovered at CERN, at the Large Hadron Collider, after almost 50 years of hunting. And the reason is that only the Large Hadron Collider could achieve the energy needed to produce the Higgs boson at an acceptable rate. And third point is that the energy produced in the collision corresponds to a given temperature. There is a relation between energy and temperature, and the temperature that is produced in the collision of the LHC corresponds to the temperature that the universe had 1 millionth of a millionth of a second after the Big Bang, because as I told you, the universe was very hot and then it cooled down, and so the temperature that we are able to reproduce in the lab corresponds to an age of the universe which was really a small fraction of a second. So in order to be able to study these very nice things coming in the collision, we need to detect the results, the products of the collision of the two proton beams, and we do so by surrounding the collision point by high-tech instruments called particle detectors, which are used in principle to detect, register, reconstruct, identify, measure every single particles, actually not all of them, but most of the particles produced in the collision. So to give us a picture of the collision event, and from this picture then we can interpret what really happened in the collision. So the most powerful accelerator ever built by mankind is the Large Hadron Collider, and it's a 27-kilometer ring, 100 meter underground. So this is an aerial view of the Geneva region. So here you can see the Alps, Geneva Lake. Here you see the airport. These little white lines indicate the border between Switzerland here and France, and this yellow circle indicates the location of the 27-kilometer ring of the Large Hadron Collider, which of course is not visible on the surface because it's located underground. So it started operation in 2010. We had the first period, so-called first run, between 2010 and 13, which was very successful. The accelerator produced unprecedented energies, and this was culminated with the discovery of the Higgs boson. Then we had 2 years of shutdown or stop in order to perform some repairs and maintenance work, and then we started again operation in this year, in 2015, at almost a factor of 2 higher energy. So at the moment we are operating with much higher energy beams. So the two proton beams collide at 4 points of the rings, where in 4 big underground caverns, 4 big particle detectors experiments have been installed. Their names are Atlas, CMS, ALICE, and LHCb, and Atlas and CMS are those that have discovered the Higgs boson, but LHCb and ALICE have also very interesting goals, and I can of course expand on it if there are questions afterwards. I would like to stress that Finland has made very important contributions to the LHC project, in particular now to the ALICE, CMS, and also in the past also to Atlas, but they're also involved in other very important projects at CERN. CERN has a very broad diversity program with nuclear physics and also future accelerator technique, or even studies of clouds, and etc. So Finland is a very strong partner in a broad spectrum of activities at CERN. So a few numbers to show you the challenges of this project, which is actually one of the most ambitious projects in science ever. So again, this is a nice picture of the underground tunnel. The backbone of the accelerators, which allowed us to achieve unprecedented energies, is a set of 1,200 high-tech superconducting magnets, because you need to produce very strong magnetic field, so you need superconducting material, and superconducting material work at a very low temperature. So the LHC works at a temperature of 1.9 Kelvin, which is just 2 degrees above absolute zero, correspond to minus 271 degree Celsius. And actually, which makes the LHC the coldest place of universe, because I mentioned at the beginning the universe had origin from a big explosion, and then it cooled down and expanded and cooled down. So if you ask what's the temperature of the universe today, well, the average temperature is 3 Kelvin, and the LHC works at 1.9 Kelvin. When the machine, the accelerator operates at the design performance, in each beam there are something like 200,000 billions of protons circulating in one direction and in the opposite direction, and they collide in the experiments 40 million times a second. So it's really a fantastic and very challenging and complex accelerator. The experiments are also very complex and very challenging, and they require a jump in the concept and technology. So for instance, this is the Atlas detector. It is 45 meter long, 25 meter high. To give you a better idea, it's half the Notre Dame Cathedral in Paris, and you can see here the comparison with human beings. Here you see a man and a woman, because we promote equal opportunities, so we always put both in our picture. So they are big. Why so big? Because you need to measure very high energy particles produced in the collision. And so to measure high energy particles, you need big volumes, and you can't just measure them in a little piece of material like that. Okay. At the same time, we need to reconstruct the trajectory of each one of the particles produced in the collision with very high precision, micrometric precision, where a micron is a 1 millionth of a meter. And so this detector is actually made of a core of 100 million pixel silicon sensor. So essentially, as you can see here from these events of a collision reconstructed by the CMS experiment, these detectors can be seen as giant, ultra-fast digital camera, taking pictures of the collision event. But they have to be ultra-fast because the two beams collide 40 million times a second. So these detectors have to be ready to take pictures so quickly. Of course, we do not store all of them because it will be impossible to analyze them. So clearly the question is why? Why at the end, why we decided to embark in this adventure? So the LHC was conceived and built to address some outstanding questions in fundamental physics. One question that has been with us for many, many years is the origin of the masses of the elementary particles, including the quarks and the electrons. And these questions have been solved in large part by the discovery of the Higgs boson. So this question has been ticked off now. But there are many others. As you know, 95% of the universe is dark. Okay, you know that when you look at the sky, the nice stars and planets, etc., what we see is only 5% of the universe. The rest, 95%, is made of form of matter and energy that we don't know, and they are called dark, where dark indicates first, our ignorance, and second, the fact that this matter and energy do not interact with our instruments, telescopes, etc. And so you could ask, so why do we know that, how do we know that they are there? The reason is, the proof comes from some indirect observation, for instance, motions of galaxies, which clearly tell us that based on the gravitational force, there must be much more matter out there than what we see. And this matter is dark matter. So this question is still there. So it's quite, if you want, it's quite disturbing that in spite of the big progress we have made, 95% of the universe is still dark. So, so when people ask what will be next at the LHC, well, try to understand a bit better the composition of the universe. Another question, why the universe is made mainly of matter, with very little antimatter. Where did all the antimatter go? Because at the beginning, at the time of the Big Bang, matter and antimatter were present in similar quantities. So why at some point the antimatter disappeared? We don't know, etc., etc. So I think I don't have the time to discuss the Higgs boson and the Higgs mechanism. I will be very, very happy to answer question. I want just to tell you that the Higgs boson is a fundamental piece of our understanding of how nature works. It's an elementary particle which is completely different from the other elementary particles that we had discovered before. Before the discovery of the Higgs boson, we knew 16 elementary particles. Now we know 17, and the Higgs boson is completely different. It has a key role. It has the role of giving masses to some of the elementary particles, those that have a mass. And this question, which seems perhaps quite far away from reality and from our day-by-day life, actually is very important, because if the electron and the quarks, that are the elementary constituents of atoms, did not have a mass, atoms will not stick together. And if atoms will not stick together, ordinary matter, the matter of which we are all made of, would not exist. Okay, so we are here exactly because only because the elementary particles have the masses they have. And with the discovery of the Higgs boson, we have understood at least a large part of the mechanism, not fully and completely, but a large part of it. Okay, So now let's go more to the second topic, which has to do with women in particular, but in general with people. And I would like to stress the importance of diversity in general, not only in terms of gender, but also in terms of ethnicity, tradition, age, etc. So it will be impossible to do these fantastic experiments, to study physics at this level, to build this instrument without the human brain. So at CERN work 11,000 scientists from all over the world, and 113 different nationalities. Member states countries are only 21, they are indicated here in blue, but there are many other countries that participate to CERN activities without being member states, but through international cooperation agreements. For a total of 11,000 scientists, and Finland contributes with about 100 scientists. You can see people coming from Australia, from South America, from China, from Russia, from North America, etc. And I would like to stress that these people work very well, peacefully together, regardless of their origin country, regardless of the fact that their origin countries are in conflict, or in some cases do not even recognize each other the right to existence. Now, if you think that these 11,000 scientists are all old people and a bit boring, etc., you are wrong, because if you look at the distribution by age, you see that the peak is at 26, and more than 50% are below 35, including myself. I will never move from. I'm here, I will never move from there. Anyway, so, and we have, at any moment in time, we have almost 3,000 PhD students at CERN. 50% of them stay in research, 50% go to industry, to finance, to electronics, to communication, etc. And they are very much cherished by industry, because they're very much used to work in international team. They have, of course, a very strong and analytical mentality, because this is what clearly physics educate you to. Of course, with so many young people, education is, of course, a primary goal and primary mission of CERN. So we have physics, accelerator, and computing schools for PhD students and young postdocs that started in Europe and now have moved to all continents. So recently we had a school, this year we had a school in Ecuador, last year we had a school in Senegal, 3 years ago in Ghana. So we are now giving this kind of schools everywhere in all continents. But also we have programs for school students and school teachers. And you can see here a nice graph that shows that over the past 15 years or so, CERN has welcomed 8,000 teachers, high school teachers from all countries, and actually Finland had a very strong participation with almost 500 teachers coming and complementing their education with hands-on activities at CERN. And we have every year 100,000 visitors, 40% of which are school classes. So you are all, of course, welcome to come. And to show that, in particular, Finland reacted in an extremely positive way to this program, and typically 70% of the Finnish schools participate in the CERN visit program. So many, many young people from Finland come to CERN, and so it's very good also that the Ministry of Education really supports these visits. So what about gender? This plot shows the distribution of the scientists in terms of age, working in the Atlas collaboration. In Atlas, there are 3,000 scientists, like in the CMS, and you see here the distribution by age, where you find, again, the usual peak at the lower end, so young people, but you see the graph separately for boys in blue and girls in red. Typically, the women population at CERN is at the level of 20%, but you see that this fraction tends to increase in the younger generation. So this plot here shows the evolution of the fraction of women at CERN in various categories, staff, fellows, students, etc., as a function of time. And you can see that the trend is positive, you see from over the years. The nice thing is that 20% is also the fraction of women that are involved in certain activities at the higher level of the hierarchy. So, for instance, women that are group leaders, this fraction was 5% in 2000, today is 20%. Women that are project leaders, women that are physics group conveners. If you go higher up in the hierarchy, then of course the fraction decreases, but you know, things are improving. For instance, the present president of CERN Council, and Council is the supreme governing body of the organization, is a woman. And in the future management, the one that I will have the chance to coordinate, well, we will have one woman department head out of 10, so this is not very good, but we'll have one woman out of 4 directors, which is better, and one director general out of 1, so which is good. Nevertheless, we continue, of course, to make effort at various levels. First of all, in attracting more and more girls from school and educating them, encouraging them, also with role models, but also to, so at the level of society, but also at the level of CERN to implement those social measures, nursery, parental leave, work time flexibility, that of course allow women to, to undertake an activity in research, still having family and children. So often people ask me if the Higgs boson will change our life, and my answer is that it has already. And the reason is that the very complex and high-tech instruments that we need to develop, need in particle physics in order to accomplish our scientific goals, require development of technology, which are cutting-edge technology, which often drive industry and then are transferred to society. So instruments developed at CERN find application today in a huge number of fields, from medical imaging to cancer therapy to solar panel, airport scanners, nuclear waste transmutation, etc. I would like to perhaps to mention one point. I already mentioned the World Wide Web, but another interesting point is the following. Today on Earth there are something like 30,000 accelerators, and only a dozen of them are used in fundamental research. Well, perhaps not a dozen, but hundreds of them are used in fundamental research. All the others are used for application, but they are based on the technologies developed at CERN and similar labs all over the world. In particular, many of them are used now for what is called hadron therapy, which consists in bombarding in treating cancer by bombarding the tumor tissue using protons. Protons have that, or light ions. Protons have the advantage compared to X-rays, so to the radiotherapy, that they do not expand. They go very much straight to the target, and so they do not affect the healthy surrounding tissues. So this is a clear spin-off of what we are doing at CERN. So Finland has made a very strong contribution to CERN. Finland has joined CERN as a member state in 1991, but Finnish groups have participated since essentially the birth of CERN. The participation is coordinated by the Helsinki Institute of Physics, HIP, which operates in close collaboration with 5 universities and plays a really crucial role in maximizing the returns to Finland in terms of education, spin-off, etc., of the Finnish contribution to the CERN budget. In particular, in September this year, a cooperation agreement has been signed between Finland and CERN and IIP concerning the creation of a business incubation center. This is a center which will support, an agreement which will support innovative developments of Finnish industries, for instance, startup companies, in technical fields related to CERN activities, so sensors, big data, high-performance computing, superconducting magnets, etc., etc. So this will increase the partnership at the level of technology, industry, and research between industry, institutions here in Finland, and CERN. So I'm reaching my conclusion. I would just like to mention a couple of things. I would like to stress the importance of fundamental research. I stress the importance of spin-off, of technology, etc. But let me make a step back and stress the importance of fundamental research. Fundamental research is important because it's the one that mostly stimulates ideas and creativity. And the reason is that fundamental research is just curiosity-driven and has no constraints from profit. If you do research in an industry, typically you do in the private sector, typically you do very good research, but targeted to a given product. You cannot just say, okay, today I want to do something else. No, you can't. You have to work on what you have to work. Okay? When you do fundamental research, you really have the possibility of thinking, blue sky thinking and thinking out of the box. Why this is important? Because ideas and creativity are the fuel of progress. Without new ideas and without new breakthrough, the progress sooner or later stops. The light bulb is not just the evolution of the candle. It's not that by producing bigger and more colorful candles that you get this light. This light has required a qualitative step, has required breakthroughs. And history shows that often major breakthroughs come from fundamental research. For instance, I like to bring two examples, quantum mechanics and relativity. They are discoveries, theoretical discoveries of the last century, and there is nothing perhaps more absurd, if you want, or far away from reality than quantum mechanics and relativity. Quantum mechanics has to do with the microscopic world, so has no effect on our macroscopic world. Relativity is sometimes even counterintuitive, okay? And yet, without quantum mechanics and relativity, we will not have transistors, we will not have GPS, and so our society will be very, very different. I also want to stress that, again, regardless and independently of this application, knowledge is together with the arts, is among the highest expression of human beings as clever beings. And so it justifies itself by its intrinsic value. Advancing knowledge and learning more and more is something that we human beings endowed with a brain should do, and it's our right and our duty. Okay, so I'm coming to my conclusions. I think that I wanted to cover 4 points. So at the DLHC, we look for answers to fundamental questions in particle physics and the structure and evolution of the universe, which are still unanswered. We mentioned the 95%, the dark universe. And with the Large Hadron Collider, a new era started. A new energy regime is being explored. It has already brought us a big discovery, very important one, the Higgs boson, and we hope more in the future. At the same time, we advance the frontiers of technology. Education is another very important thing, so students and young people are all welcome to visit, to come, to take part in our numerous activities, education and training activities. And stress also that it's very important, one of the missions of CERN is to promote diversity. And again, in all aspects, not only gender, but in general, ethnicity, age, tradition, etc., because diversity is really a strength of mankind, okay? The fact that we are different is a strength, and is an asset for a richer and more stimulating environment. It is also an asset for better science and for a better world. Okay, thank you.
We are a little bit late on the schedule, but may we take one urgent question? Urgent, yes. Important. Okay, here we have.
Thank you very much for a very inspirational talk. You mentioned some of the practical applications of what CERN does, but I think that most of us non-specialists conceive CERN as an institution for fundamental blue skies research, and I suspect that even most politicians see it as such. And in this day and age when there is a very depressed mood in Europe, and every country, including your member countries, are complaining about economic difficulties, I find it very encouraging that they are still willing to put 1 billion Swiss francs a year to CERN. And it somehow gives one faith in the rationality even of political decision makers. And I'd like to hear your views on or anticipation of what is happening if this economic situation still stays very bad or declines. Do you see any signs of your supporters getting nervous, and do you see a threat to the CERN budget because of the economic difficulties? And if not, what would be your advice to other areas of science that would like to stop the erosion of their funding that seems to be ongoing in most other fields?
Thank you. Thank you. Perhaps I use that. Yeah, thank you for your comments and your question, which actually will require a long answer. So I'm not so sure that we have the time to elaborate. It's a very, very good point, of course. So first of all, I would like to stress, as I said at the beginning, CERN primary mission is science. So we are doing fundamental research. That's why I wanted to conclude, in spite of all the application, etc., which are nice, which are important, to conclude with by stressing the importance of fundamental research. So clearly the mission of CERN is, first of all, fundamental research. Second, fortunately, member states, countries are still willing to contribute to the CERN budget. 1 billion, you said, to put so much money. 1 billion Swiss franc is one cappuccino per European citizen per year. So it's not that much. Okay. No. Anyway, yes. I think that that investing money in fundamental research is fundamental. It is important, especially in periods of economical crisis. Not finding fundamental research is short-minded, because again, if you don't find fundamental research, you will stop these creativities and these ideas, and sooner or later the progress will stop, as we said before. I think at the beginning of his first mandate, President Obama made a very nice speech exactly saying that. Then I don't know if then he maintained what he said, but he said something like, it's in the moment of, at times of economical crisis that one has to invest into research. So I hope that that member states, countries will continue to support CERN. There are new countries also from outside Europe that will join CERN in different status, different level, and they're very much interested to join. I think the value of CERN is the value of science, of course, is the value of technology, but also it's the social value that CERN has in bringing together people, in cutting the barriers. There are countries that joined CERN before joining the European Union, and their participation in CERN was the first step toward the European Union. So what would I advise to other countries? Well, have something like CERN, that is an international organization, something that is a status of international organization, you know, not just one country, but many countries together. This gives stability, because if one country is, is a little bit some problems, the other pull and say, no, look, you can't abandon. So the stability comes, which is what the American system, at least in our field, suffer from. In the US, a project can be cancelled from a year to another one, from a month to another one, because Congress can decide today yes, and in 1 month from now, no. In Europe, at least at CERN, I mean, for particle, I'm talking about particle physics, this does not happen because of this strong partnership among European countries. There is stability. And that's why Europe, since 1954, when CERN was founded, to really bring back the axis of research from the US, where it had moved during the war, this axis now is back to Europe, and we have the leadership exactly for this reason. Any other question?
Yeah. I think I have to be a very boring person, because when there is this discussion, it's so disgusting to interrupt it. But now there is a press should be here, and I ask these people to stay in the lecture room. And now, in the end, I want to thank Angela, Irma, and Fabiola. Thank you so much for your presentations. It was really a great opportunity for us to have you as our guests. Thank you.